Hi guys, welcome. So we'll learn about depth first traversal in the graph data structure. So we know a graph data structure is where one node might be connected with several other nodes, and it has a tendency that it can circle back. For example, I am a vertex in the graph. I know someone and you also know someone, and that guys knows both of us. So it would create a circle and things might go, if you start looping with not a proper strategy, you might end up having the infinite loop, like one is going to two three, coming back to one two three, something like that. So we need to avoid those loops. So there is a way is we keep if a node has been visited in a boolean flag call as the visited, it's an array which we maintain. So I have explained it very well in my last tutorial. So please jump in there. I'll also cover some part of it in this tutorial, and we'll also see hands-on coding. So breadth first up, traversal is that once you have a node, then if you will first print the immediate connected nodes or the adjacent nodes, and then you go one level deeper, that's how it's called as width first. So whatever is the, at the width of this direct connected, then you pick A and the direct nodes of A you will print, then B. That's how traversal means, printing or going to those nodes. So this is width first against the depth first, where you will first go deep down, then you will print, come back, then you go again deep down to other guys, something like that. So it's other way. These are two very common techniques, even for the trees and even for the graph. Trees are special, kind of graph basically. So we need to use the we need to use the queue for this purpose. So let's get started. We will take the input as from what vertex you need to start this, right? So we'll say the vertex. Now again we would maintain the record of this is visited before or not in the boolean, which is called as visited. And what we would do is whatever the point we are visiting, first we would mark that point uh, as visited true because it's already here, right? And then we will create a queue. So a linked list can be used as a stack as well as a queue, both ways. So I would make a integer queue here, and I would just call queue, simple. And then I would say like this here. So I have a queue. Now what would I do is first I would go to the elements which are the nodes or the vertex which are near to this. So to do that we have the adjacent list already available for this. So we would bring it up whatever are those points for V, and we will start iterating over it. So since we have given the number of the node in our graph, so we'll just say adjacent or neighbors, whatever, NEIGH, let's say neighbors in this. So we would say all the neighbors. So first we would print the immediate neighbors or immediate adjacent. This is our graph and we are trying to do the width first. So zero's neighbor is 1 and 3, so we'll print them first. Then the neighbor of 1 is 2, we'll print that, and neighbor of 3 is 4. So in that sequence things should go, right? So once we come here, we will just check if this node is already visited or not. So we would see that if it's in the part of NEIGH, actually, neighbor has been visited or not. So in case if it is not visited, then we have to add it in the queue. So we would say queue dot add. So we would add this neighbor here. And whenever so one more thing is we have to add this first guy also, whatever when we will start. we would have the first guy here, which would get added in the queue. So this guy has been added in the queue. Right now, what do we do is we will have the queue. If queue is not empty, we will try to iterate everything inside the queue. So for example, as soon as you are inside the queue, first thing is you would take out the first element of the queue, and that element you can call it as vertex, for example. So what you need to do is whatever are the adjacent points or the immediate neighbors of this vertex, you need to take them out. Once you would get those vertex, then you would figure out if those vertex are visited yet or not. If they are not visited, you will add them in queue, and then it would loop over for all the vertices. And as soon as you come back here, basically here, so whatever is the vertex you would get here, you would assign that it has been visited. So let's do that. Whatever vertex, oh, I had a typo here, it's not vertex, it should be vertex, BERTEX, it's not a text file. So once you do that, essentially quick revision. We created the visited boolean, and then we marked the first element. We added it in the queue. This can go down. It doesn't matter actually, but yeah, let's keep the code clean. Now you're in the queue, you have the first vertex. You mark that as true actually. Whatever is the current vertex, you marked it as true, and then you are trying to loop it over for all the neighbors. And as soon as you come here, you can also do a system.out.print, and you can have it as width first whatever is the vertex which is in the front of the queue. And then you can also once you start here, you can say bfs Breadth First Traversal, and then you can run this. So we might need to debug a little bit here. There is some problem actually. Otherwise, from 0, it is supposed to go to the next element. Okay, so I got it. Basically, this is a typo. This should be while. That is why we were just able to see only the first element and not the depth. So right now we see all the elements or all the vertices in the graph. So this is how we did the width first traversal of a graph. Graph looks like this, and then we would print 0 and then the level 1, which is 1 and 3, and then level 2, which is the next level 2 and 4. And if there are certain other levels, so when we print level by level, that is called as the width first. So what we did is we start from a particular node, and then we created an array so that we avoid duplication, like we don't visit that node again and again. That's why we have this. If we will not have this, then there might be trouble. Like if you're not checking, then we might go again and again to that node. So there will be some duplication. That is why we check that. So we created that visited boolean, and then we created a queue. So first we put the first vertex in the queue, and then until the queue is not empty, we are looping over. So we will just get the first element out, which we call it as pool, from the queue, and then we will get all the adjacents from that for that vertex. Then we'll figure out if that vertex adjacent vertex was not been visited before, we will mark it as visited and add in the queue. Why we mark it as visited? Because if through other senses it comes, like through other vertices, we don't have to traverse it again. So that's the purpose of this. And then this looks exactly like the width first approach. So I'm sharing the code. It has both width first and depth first. As part of next tutorial, we will look a little bit advanced graph. Where we'll make the airline project. So instead of just giving the vertices as numbers like indexes 0 and 1, we'll have the proper name. So thanks for watching, and please like and subscribe my video. See you in the next video.